Hello everyone, welcome to IGCSE with Optimus. Subscribe to our channel and hit the bell icon to never miss an update on our IGCSE content.
Hello everyone, welcome to our channel IGCSE with Optimus. In today's video, we are going to discuss about paper from October-November series 2024 and the paper code is 21. This is for subject physics. See, the first question in the paper, it says define density. So your answer for definition of density would be mass per unit volume. So density is mass upon volume. The next question, it says figure 1.1 shows a cuboidal glass block. A student measures mass m of the block and the three dimensions, that is x, y and z. The measurements are shown in the table. They have given the quantities, and if you see in the measurement table, they have given the true values and also the uncertainties in the values. The first question says determine the density of the glass. Know that whenever we are given with the quantities and we are supposed to use those quantities for calculating another quantity, we will be only considering the true values and not the uncertainties. So density is equal to mass upon volume. The mass of the object is 0.243 kilogram. So it will be 0.243 divided by, for volume, we will be multiplying the length, that is x, y and z. But note that these values are given in centimeter, and on the answer line, they are asking us to write the density in meter cube, that is kg per meter cube. So we will have to convert all the quantities from centimeter to meter. So it will be 5.41 into 10 raised to minus 2 multiplied by 11.09 into 10 raised to minus 2 multiplied by 1.62 into 10 raised to minus 2. Now if you calculate this, you will get answer 2500. So the density of the object is 2500 kilogram per meter cube. The next question is calculate percentage uncertainty in the density. So to calculate density, we have used mass and the three dimensions of the lengths. So to calculate their uncertainty, the percentage uncertainty in the density, we have to calculate percentage uncertainty in each and every quantity. So for mass, it is 0.001 upon 0.243 into 100. For x, it is 0.01 upon 5.41 into 100 plus for y, it is 0.01 upon 11.09 into 100, and for z, again it is 0.01 upon 1.62 into 100. So which formula we are using here? Percent uncertainty is equal to absolute uncertainty upon true value multiplied by 100. Now, if you calculate all the values that are given above, we will get uncertainty as 1.3. So the percent uncertainty is 1.3% in the value of density. Next, the true value of the density of the glass is different from the answer in B1 because of a systematic error in the measurement. Suggest one possible cause of this systematic error. So zero error or the error in calibrations of the devices can be considered as a systematic error. So we can write the reason for this systematic error could be zero error, that is, for example, balance is not calibrated to zero before recording mass of the object. We will move to the second question. Second question, the first part A, it says define linear momentum. We know the formula for linear momentum. It is mass multiplied by velocity. So we can write the definition of momentum as product of mass and velocity. Okay. Question B, it says a car of mass 1800 kilogram is moving in straight line. Figure 2.1 shows the variation with time t of the momentum p of the car. So on y-axis they have given us momentum value and on x-axis they have given us time. You can see on y-axis the value is increasing. It means momentum is changing. You can see that initially the momentum is 0. So you can say here the speed of the object is going to be 0. Why? Because momentum is mass into velocity. Mass is 1800. If momentum is 0, it means the velocity of the object is also 0. Again, at this point, the object is coming to rest, meaning the speed will be 0. Whereas at this particular point, the object shows maximum momentum, meaning at this point object will have maximum speed. Also, if we see the x-axis, it is time and y-axis is momentum. If we take any two values and we calculate change in momentum and we divide it by time, we are going to get gradient of the graph, and this gradient of the graph is also going to be the force acting on the object. Why? Because force is rate of change of momentum, that is change in momentum upon time. First question, calculate maximum speed reached by the car. As we have marked on the graph, maximum speed is when the object is at maximum momentum. So the maximum momentum of the graph or the object is seen somewhere over here, and this point is 7.2. So we can write maximum speed is equal to maximum momentum upon mass of the object. So for V, we are using formula momentum upon mass. So what is the maximum momentum that we are seeing? It is 7.2 multiplied by 10 raised to 4. So it is 7.2 multiplied by 10 raised to 4 and the mass of the object is 1800 kilogram. Okay. So if you do 7.2 into 10 raised to 4 and divided by 1800, you will get speed of the object, that is 40 meter per second. So at this point the speed of the object is 40 meter per second. Question 2, calculate maximum kinetic energy of the car. Its simple formula for kinetic energy, half mv square. So that is half multiplied by mass of the object 1800 and square of maximum speed, that is square of 40. So it is 0.5 into 1800 into square of 40. The answer is 1.4 into 10 raised to 6. joules. Next question, show that the acceleration of the car at time 4 seconds is 5 meter per second square. So we are supposed to find acceleration. Okay. We know the formula for force. Force is mass multiplied by acceleration. So acceleration will be force upon mass. Now, as we have discussed here, to find force, what we can do? We can find the change in momentum of the car. At 4 seconds, the momentum of the car is having this value, which is 3.6. So between 0 to 4, the change in momentum upon time will be 3.6 into 10 raised to 4 upon 4. Which is 9,000 Newton. Substituting that here in the equation of acceleration, it will be 9,000 upon 1800. The answer will be 5 meter per second square. Hence proved. Next question, determine the distance traveled by the car between times 0 seconds to 12 seconds. Now, if you see here, we can represent the same graph as the speed time graph also. The graph is something like this. If we represent the same graph in speed time, here the speed is 0, here the maximum speed is 40, and here the time is 12 seconds. So the distance can be calculated as area under graph, and that will be half into base into height. That is half into base is 12 and the height is 40. The answer is 240 meter. Next question, on figure 2.2, sketch the variation. On figure 2.2, sketch the variation with time t of the acceleration of the car. Acceleration A of the car in B from 0 to 12 seconds. So you can see that between 0th second till 8th second, the graph is having constant gradient. So from here, we can write the graph is having constant gradient, okay, meaning the graph has constant or car has constant force. Now if the object has constant force, it means its acceleration will also be constant. We already have worked out that acceleration, and that acceleration is 5 meter per second square. So between 0 to 8th second, it will be a flat line at 5, indicating that the acceleration is constant between 0 to 8 seconds. Now, what's happening after 8 to 12 seconds? At 8 seconds, the speed is 40. At 12th second, the speed is 0. So, it is actually deceleration. We can write 0 minus 40 upon time, that is 4 seconds, between 8 to 12, 4 seconds, it will be minus 10. So between 8 to 12 seconds, the object is decelerating. Deceleration is negative acceleration. So in this graph, if I have to show negative acceleration, then it will be minus 10 in this quadrant of the graph, and we will be joining a line like this, straight line. So between 0 to 8, object is accelerating with constant acceleration of 5. Between 8 to 12 seconds, the object is decelerating with constant deceleration of 10 meter per second square. We will move to the third question now. The third question says, state what is meant by the work done by the force. Okay. So it says state what is meant by the work done by the force. We know the formula for work done. Work done is force multiplied by displacement. So we can write work done is product of force and displacement in the direction of force. Question B. A block of mass m is raised vertically at constant speed. Now, if you are raising the object at constant speed, it means acceleration is 0. The net force will be 0, meaning the downward force will be equal to upward force. The vertical height gained by the block is delta h as shown in figure. Derive an expression in terms of m and delta h for the change in gravitational potential energy delta EP of the block. State the meaning of any other symbol you use. So you know that work done is equal to energy transferred, and that itself is GPE gained by the object. So we know the formula for work done. It is F into displacement. The force while raising the object, as we discussed, at constant speed, the downward force has to be equal to upward force. So the downward force is weight of the object, that will be mg. So when you are raising the object upward, then also you will be applying force equal to mg. So it is mg, and that makes the difference in height of delta h. So S will be delta h, and so GPE gained is equal to mg delta h. Next question. An electric motor has an input power of 900 watt. We are given with power here. The motor takes 1 minute, that is time, to lift a load of weight 240 Newton force and at constant speed through a vertical height of 150 meter. Resistive forces are negligible. Show that work done by the motor on the load is 1 minute is 36 kilojoule. We just now worked out the formula for work done. It is force multiplied by displacement. How much force that we are supposed to apply for having constant speed? It should be equal to the weight of the object. So it will be 240, and we are lifting it to the height of 150 meter. So 240 multiplied by 150, we get answer 36,000, which is 36 kilojoule. Next question. Determine the useful power of the motor. So power is equal to work done upon time. The work done is 36,000 divided by the time. Time is 1 minute, so it will be 60 seconds. Okay, so 36,000 upon 60, we get answer 600. So the useful power developed is 600 watt. Use your answer in C2 to determine the efficiency of the motor. Efficiency is output power upon input power into 100. Note that it is total useful power output upon input power into 100. How much is the useful power output? It is 600. And how much was the total power input? It was 900 watt, which was given here. Okay, so it is 600 upon 900 into 100. And that gives us answer 66.7. So we can write 67%. Next, some power wasted in the motor is dissipated by the resistance of its coil. The dissipated power is 280 watt. The coil of the motor is made from wire of total length 23 meter. The wire has cross-sectional area of 2.6 into 10 raised to minus 8 meters square and is made from metal of resistivity 1.7 into 10 raised to minus 8 ohms meter. Calculate the current in the coil. Okay. Now, looking at the data, you should understand they have given us power and they are asking us to find out current. Okay. So, which formula links power with current? We can write the formula as I square multiplied by R. So, for I, we can use formula under root power upon R. So, we have power is 280, but we don't have the value of resistance. So we will first work out the value of resistance from the other data we have. So we know resistivity is R multiplied by area upon length. So for finding R, we can use formula rho into L upon A. Rho is resistivity, which is 1.7 into 10 raised to minus 8. Length of the wire is 23 meter and the area of cross section is 2.6 into 10 raised to minus 8 meter. Now if you calculate this, you will get 1.7 into 23 divided by 2.6, that is 15 ampere. Okay, so we will divide current value over here and we will get under root 280 divided by 15, the answer is 4.3. Note that here it is not ampere, it's ohms. So it is 4.3 ampere. That's the answer for current. We will move to the next question, that is question number 4. It says define Young's modulus. So Young's modulus is the ratio of longitudinal stress to longitudinal strain. So when we say longitudinal, we are actually talking about the change in the length of the object. Next, question B says that a metal wire P that obeys Hooke's law is stretched within the limit of proportionality. On figure 4.1, sketch the variation of tensile force F in the wire with its extension X. So we know that as long as we are applying force until limit of proportionality, the load and extension will be directly proportional to each other, and so their graph will be a straight line passing through the origin, something like this. State the name of the quantity represented by the gradient of this line. Now the gradient of this line will be delta F upon delta X, which is K, that is spring constant of the object. So it is K divided by F upon X. State the name of the quantity represented by the area under the line in figure 4.1. So the area under the line of the graph will be the work done in stretching the wire. Next, another wire Q is made from same metal, has twice the Young's modulus of the metal wire P. In B, wire Q has same volume as wire P but has double the cross-sectional area of the wire. Now, what is the formula for volume? The formula for volume is area into length. So if you double the area to keep volume same, you will have to divide length by 2. So if area is doubled, to keep volume same, the length must be halved. So the first point would be, for same volume, if area is doubled, then length is halved. Okay, then the extension is directly proportional to length and inversely proportional to area and Young's modulus. Why so? Because we have the formula for Young's modulus. It is F into L upon A into small l, or you can say x. Instead of writing small l, we will write x. So x will be F into L upon A into y. Okay, we'll just work out the equations now. For the first wire, the extension is, let's say, x1, and for the second wire, the extension is x2. So for first wire, we will write F into L divided by A into A into y. For second wire, force is same, the length is halved, so it will be 0.5 times of L divided by area is doubled, so it will be 2A, and even the Young's modulus is doubled, so it will be 2 into y. So we are now remaining with 2 multiplied by 2 upon 0.5, and that gives us answer 8. What that means, in second wire, the extension will be 1 divided by 8 times as that of first wire. Okay, so if length is halved, area is doubled, and the Young's modulus is also doubled, the extension in second wire will be 1 divided by 8 times as that of extension in the first wire. Question number 5. Potassium 40 undergoes beta minus decay to form a nuclide of element X. Particle Z is emitted during the decay. The equation for the decay is shown, which is given over here. State the values of P, Q, R and S. We know that during beta decay, the mass number of the particle remains unchanged and a neutron changes into proton. That's why the proton number increases by 1. So here, value for P will be 40 because the mass number remains unchanged. R is the mass of beta particle, which will be 0. Q is the proton number, which increases by 1, and so it becomes 20. And S is the charge on beta particle, which is -1. Next, state the name of particle Z. So you know that whenever there is beta minus decay, a particle comes out from the nucleus and the name of the particle is antineutrino. Okay. Next, state the name of the class of fundamental particles to which both beta minus particles and particle Z belongs. Beta minus particle is similar to electron, and so we say that they belong to a group called as leptons. Next, determine quark composition for an alpha particle. So you know that alpha particles, they contain 2 protons and 2 neutrons. Each proton composition is 2 up quarks and 1 down quark, whereas for each neutron, the composition will be 1 up quark and 2 down quarks. Okay, so if you multiply this by 2, you will have 6 up quarks and 6 down quarks. So the composition of alpha will be 6 up quarks and 6 down quarks. We will move to the next question, question number 6. They are saying 2 coherent sources X and Y of microwave of frequency 2.5 into 10 raised to 10 hertz. What is this frequency? Are at distance of 0.18 meter, okay, apart in a vacuum as shown in figure 6.1. There is a phase difference of 90 degrees between the waves emitted at the two sources. Now understand what this phase difference 90 means. It means that suppose first wave is emitted and it travels like this. So when the first wave is at 0, the second wave already covers the distance of 90 degrees, meaning the wave starts from somewhere here, like this. Okay. So when first wave is at 0 angle, second wave already has covered the angle 90 degree. Okay. That's why the phase difference between them is 90 degree. Next, a microwave detector moves along the line PQ, which is parallel to the line joining the two sources and 2.3 meter away from it. What is this? Capital D. Point O is on the line PQ at a position that is equidistant from the two sources. So they are saying that point O is at same distance from the two sources like this. Okay. Point A is the position on the line PQ where the intensity of the microwave is greatest. Now see, usually we see the greatest intensity, or we say intensity maxima, at a point which is equidistant from the sources, provided that these two sources of light are having no phase difference or zero phase difference. Here the waves are moving with phase difference 90 degree. So definitely the crest and crest of waves or trough and trough of the waves will not overlap each other at same distance, that is at point O. So the overlapping of crest and crest will be slightly away from point O on the either side, that is on the above side of O or the below side of O, but it will not form its maxima at point O. They are asking, explain why the position of greatest intensity is not at point O. So, for intensity to be maximum at O, there should be zero phase difference between waves. Waves coming from X and Y have 90 degrees phase difference. Next, on figure 6.1, draw a cross to show the position of the point on line PQ where the intensity maximum, that is the closest to point A, occurs. Label this point B. So, if here we are seeing intensity maxima, then somewhere here we will see point B, which is the intensity minima. Okay. Next, show that the wavelength of the microwave is 0.012 meter. So it's a microwave and they're asking us to find out the wavelength. We can use formula wavelength is equal to V upon F, where V is the speed of microwave in vacuum, 3 into 10 raised to 8, and the frequency they have given over here, it is 2.5 into 10 raised to 10. So 3 into 10 raised to 8 divided by 2.5 into 10 raised to 10 We get answer 0.012 meter. Next, for point A on line PQ, determine the difference in the distances delta x traveled by the microwave from X and the microwave from Y. So, as we explained in the diagram above, if let's say this is the wave coming from X, so its angular distance will be 0 over here, 90 over here. Okay, so when first wave covers distance 90, it reaches to its maximum amplitude, which is over here. Since the wave between X and Y, the waves X and Y have the phase difference of 90, wave Y will start from here, and when this is at 0, wave Y will be at its maxima, meaning something like this. Okay, so wave X is the red wave, this one, and wave Y is this wave. Wave Y always covers this distance greater than wave X, and this can be considered as delta X. So this delta X will be equal to the wavelength 0.012 divided by 4. Why 4? Because this is 1/4 of the total wavelength. Okay, like this part we are talking about. So this is 1/4 of the total wavelength. So 0.012 divided by 4, it is 0.003. Okay, next question. Use the formula for the double slit interference of the light to calculate the distance between the adjacent intensity maxima. So they are asking us to find out fringe width. The formula for fringe width is x equals to lambda d upon d, where lambda is the wavelength, which is 0.012. D is the distance between the slits and the screen, which is 2.3 meter, divided by the small d, which is the distance between two slits, which is 0.18 meters. Okay, so 0.012 multiplied by 2.3 upon 0.18, and the answer we get is 0.15 meter. Next, question number 7. It says figure 7.1 shows two resistors connected in series with the cell of EMF 1.5 volt and the internal resistance is 0.28. So this 1.5 volt is the EMF of the cell. One of the resistors has resistance 1 ohms, the other resistor has resistance R. The terminal PD across the cell is 1.36 volt. Now what is terminal PD? We know that if the cell has internal resistance, then the charge has to do some work to come out of the cell against that internal resistance. So charge cannot carry the amount of energy exactly like EMF because it spends some energy before coming out of the cell. So the terminal potential difference is equal to the EMF of the cell minus work done against R, where R is the internal resistance. They are asking, show that the current I in the circuit is 0.50 ampere. So to find current, we can use formula voltage upon resistance. Here we will use voltage value, that is work done against R divided by small r, that is the internal resistance. So work done against internal resistance is 1.5, which is EMF, minus 1.36, which is terminal PD, upon R, and the value of R is 0.28. So 1.5 minus 1.36 upon 0.28, we get answer 0.5 ampere. Okay. Next, calculate the combined resistance of the two resistors. So the combined resistance is equal to voltage upon current in the circuit. We already have got to know the current value. The current value that is going through both the resistors is 0.5 ampere. So the terminal PD is the remaining voltage for the circuit after charge spends energy against internal resistance. So what is the terminal PD value? It is 1.36 upon the current, which is 0.5 ampere. So 1.36 divided by 0.5, we get answer 2.72 ohms. So the total resistance of two resistors in series is 2.72 ohms. Use your answer in A2 to determine the resistance R. So we know that R can be worked out as 2.72 minus 1.0. So it is 1.72 ohms. Resistors in series, so their values are added. 1 plus R is equal to 2.72. So R will be 2.72 minus 1, that is 1.72. Question B. The circuit in figure 7.1 is disconnected and the two resistors are now reconnected to the cell in parallel with each other. On figure 7.2, complete the circuit diagram to show this arrangement. Okay. Now those two resistors are connected in parallel to the circuit, meaning battery. So you can show them like this. This is R. And in parallel with R, we have resistor 1 ohm. Okay. Next, explain without calculation whether the terminal PD across the cell is now less than, equal to, or greater than 1.36 volt. So if the resistors are connected in parallel, the external resistors 1 and R, they are connected in parallel, the total resistance of the external circuit decreases, because of which the current increases. So first we will write about that. When resistors are connected in parallel, the combined resistance decreases and hence current in the circuit increases. Now the work done against internal resistance increases. Why so? Because it will be V is equal to I into small r, where small r is internal resistance. If I increases, then the work done against internal resistance will also increase. Subsequently, the terminal potential difference will decrease. So the terminal potential difference decreases. So this was the last question in the paper. We are done with this paper, which was 9702 ON24, paper 21. Please subscribe to our channel and share this video with your friends. Stay tuned for the new videos coming up regularly for physics and the other subjects of A levels and IGCSE. Thank you.